Let's discuss a question on heat transfer. This is from radiation. So you have two spheres, concentric sphere. One sphere, first sphere is inside the second sphere. Okay, and we need to find out the view factor F22. So basically, for each of the body, you can apply that summation of the view factors is equal to 1. That holds for each of the body. So for surface 1, when I write for surface 1 when I write, so f11 plus f12 has to be 1. Now f11 surface 1 is again convex surface, so f11 is basically there's hardly anything because it goes, I mean, radial, and when f11 is 0 basically. Okay, so f12 is 1. It's a convex surface, so f11 is 1, so f12 is 1. Now for surface 2, we can write f22 plus f21. Okay, that is 1. F22 we cannot say because f22 there is some portion of radiation that enters to 1 also, so this we cannot directly say. So now, so individually we have written, but there is also called the reciprocity rule. This is summation rule for each of the surfaces. Summation rule for surface 1 and then the summation rule for surface 2. Now we apply the reciprocity rule, okay, which means that A1 F12 is equal to A2 F21. So now we need to get F21 because then I can substitute in this and get F22, right? Because we want to get F22. So F22 from this equation I get, but I need to get F21. So F21 from this equation is A1 by A2 F12, and F12 we got as 1, so it's basically A1 by A2. So A1 is what is the surface area of a sphere? It's 4 pi r square. So 4 by r1 square by 4 pi r2 square. So basically r1 square by r2 square is my F21. So I go back here, substitute it here. So F22 is 1 minus F21, that is 1 minus r1 square by r2 square. So the answer from this we get is D. So this is again a standard uh, shape factors problem. Okay, so apply summation rule for each of the surfaces and then reciprocity rule for combining these two surfaces. Thank you. D is the answer.